Today we are going to talk about basics of software or programming. Now, this is a very broad topic, and I'm approaching this topic from a point of view or an angle, and you may think or you may have heard of the same topic or have some idea already, which may not exactly match with this approach. But I think you'll hopefully, if you hear it, you'll learn something useful. So let's say if you have already been doing the software, probably this is you have probably heard of all this. But if you're new to the software, new to the computer, this may be something you should like knowing about. So software mainly has so when you say software or software programming or somebody who is a software engineer, what basically means is that the person who writes software means writes code. So then software has basically two main components. So let's say when you write the software, so let's assume that is called a software program. Right? So that you write, and then a software program, if a computer, let's say this is a computer, hopefully you get the picture. So the way this program, what you wrote, it can interact with the hardware is you have to transfer it to a language which you call machine language, which your hardware can understand. So there is something called compiler which does the job. It's called compiler. So C-O-M-P-I-L-E-R. So compiler does the job. So it takes your program and converts into machine language so that the hardware can understand. So let's say, for example, if you write a C program, then you need a C compiler, and that would make the program to be understood by the hardware. Now the way the compiler works is that the compiler is specific to an operating system. So let's take an example. Let's say again, if you write a C program, let's say sum.c. So the way the compiler would work is that it will take your program and it will make sum.exe. Now what is there in the sum.exe is really so let's say this is your compiler and this is the, let's say, operating system, which ultimately is the gateway to all the hardware interface. So usually you have separate compiler for separate operating system. So let's say if you are developing the program on a Windows machine or Windows operating system, then your compiler would be very specific to the Windows. So that means if you when you take your sum.c and tell the compiler to create a machine language or some exe program so that your hardware or computer can understand, what it internally does is it basically interacts with the operating system, which is your Windows, and see how really the internals of the program. Let's say sum, essentially it will add, given two numbers, let's say it will add. So that basic add operations, it will take the help of operating system and then try to see how the hardware would eventually add it. So I think I know this sounds probably a little bit too vague, but think about it. Compiler to interact with really to machine language, it has to interact with the operating system. It cannot go directly to the hardware. So for if you develop on a Unix operating system, then probably you need a Unix compiler for C. So I think that sort of hopefully gives you a good idea. So operating system. So to get to the point where you started, so we have your software program. Now software program is kind of a confusing term because compiler, everything is a software program. Compiler also is a software program. Even your operating system is also a software program. So maybe you can write like a application program or an application which is specific to what you are doing. So that's called application program. Oops, I got extra line. Let me remove it. Okay, so application program. So here we have an application program, let's say, which is sum.c. Then you have your C compiler for Windows. Then you have your Windows OS, and that will interact with, you can say, Intel PC, so which is close to the hardware what we can get. So your application program is this. So let me take a different color just to make things a little bit interesting. So let's see. So then this would go to Windows, and then this would go to Intel PC. So that's sort of the flow. So I think that sort of gives you a good idea. So basically what you are really doing is that taking something which you can understand. So to create sum.c, let's say you typically use something called maybe you can write using Notepad. So you open a text editor and then you write the programs. So this is something which you can understand, because you cannot really, so that somebody can argue, why not start creating the program which computer can understand, you can, or the hardware can understand, because that's a machine language which is difficult for you to understand. So all really it is doing it is that it is sort of you can think like a transfer mechanism. You're writing something which in a language which you can understand, which is, you can think any software language is sort of some versions of English, however complicated that may sound, and then you transfer, you go through a certain processes like compiler, so to make it convert it to a language which your hardware can understand. So that's all really is happening. Now while this process goes on, maybe you don't write everything. So let's say, for example, if sum now, or maybe let's say if you are doing you're doing a factorial of a number. Okay, let me change the color again. So if you're, let's say if you're doing a factorial of a number, so you may not like to create a factorial. Let's say you may not want to write your own algorithm for creating a factorial. So they are maybe available through a library. So there is something called library. So these are basically library of programs which is like a reference material. So for example, instead of you writing your own factorial function which will do the job, you take the help of the library which does where someone has already written the program to calculate the factorial. So you take help of a factorial function and then call it to do your job. So let's say in your program, let's say you are doing a factorial, and then you're doing a factorial of a number, and then maybe multiplying it with 2. Then multiply with 2. So these are the two jobs you are doing. So instead of you developing your own factorial program, you call a library which has factorial program, and then you take the output and then multiply with 2. So this sort of, these are called, so the point I was trying to say is that, because I was trying to explain the concept of library. So the library, what is a library? Library in a software programming context, a library is a set of utility programs which has been written by someone else, and you take help excuse me, while developing your program. So I think that hopefully that gives you a good idea of libraries. In a standard software, nobody writes everything from scratch. It's always a good idea not to, they call, reinvent the wheel, meaning you don't want to do things which has already been done by someone else, and then and that's more efficient programming. You can reduce your time and etc etc. This is also used for creating standards. So let's say if for example, let's say how to display a, let's say you are writing some program which will display a report in a nice format. So instead of every programmer to create their own layout for the report, somebody can provide a library which company has standardized how the display of report look like. So and then and maybe that will have a function called display report, which is you pass your text of the report, and then that will the display report function would create some nice layout. So that's sort of somebody can create a library with which has a lot of the display report functions and provide all the programmers of the company. So I think that sort of hopefully gives you a good idea of the software programs. So basic thing again is an application program, a compiler, and library. Thank you.